Hi. I see that some attendees are slowly coming into the session. Maybe we give it 1 more minute and then we can start. First of all, by welcoming everybody to this session organized by the ECB. So organized together with Luca De Dola, who should be able to join us soon. And I would like to ask everybody to put questions in Q&A, and I will also put in the Q&A a message while Erwan speaks to please put questions in the Q&A and keep the questions for the end so that we can have first presentations, and then here's Luca, welcome. We can first do the presentations, 20 minutes, and then we have 10 minutes for discussion for each paper. So we start with Erwan, if you want to share.
Yes. Can you see them?
Yes, perfectly, thanks.
Yeah. Shall I go on? Yeah.
Very good. Yes, please go on.
Okay. So thank you for having me in this session. So today, what I'm going to do is to present a paper. It's a joint work with Fernando Alvarez, Andrea Ferrara, Hervé Bihan, and Francesco Lippi. So in this paper, what we do is to investigate a sufficient statistic result which applies on monetary policy shock. So the starting point of the paper is the following. It's this sufficient statistic result that links the cumulative output response to a monetary policy shock to a simple, two simple moments of the price change distribution. And this result, we will test this result using data. Just I want first just to look at to give you some insights about this theoretical result. So this theoretical result is coming from a multi-sectoral economy where price setting is frictional. Frictional in the sense that firms they have an adjustment cost to change their price, and this adjustment cost is a random menu cost. So they draw a random menu cost at any time, and they have a trade-off between changing their price and they have to pay this cost, or not to change their price, and in that case the price won't be equal to the value maximizing current profit. There will be a price gap, and this price gap will induce some profit losses. And here, when there is a monetary policy shock, firms may adjust or not to this shock at a given time, and it gives this general result that the monetary policy shock might have real effects. And here, the sufficient statistic result says that this output response to a monetary policy shock. So here it's in cumulation. So you should think of it as the area under the impulse response function of product in sector J. So delta is this small monetary policy shock. This cumulative impulse response will be equal to this ratio, and this ratio is the kurtosis of price changes, non-zero price changes. So this is a moment of the price change distribution, and another price moment is the frequency of price adjustment. So here, to give you the intuition behind this relationship and to understand how it fits the common model of price rigidity, think of a Calvo model, for instance. So in a Calvo model, the kurtosis of price adjustment, of the distribution of price adjustment, is equal to 6. So in that case, you can see here that it's becoming very simple. The cumulative impulse response function will depend over 1 over the frequency. So typically in a Calvo setup, the output response will only depend on the frequency. If frequency is high, you adjust very frequently, and in that case, you have a small output effect for monetary policy shock, and if frequency is very small, the output effect will be very big. And then you have another polar case where the menu cost, the fixed menu cost model, in that case, the kurtosis will be equal to 1. And as you can see, for a given frequency, having a kurtosis of 1 means that the output response will be smaller than if the kurtosis is equal to 6. And here it has to do with the selection effect. In a Calvo model, you have no selection effect, so kurtosis is equal to 6. And here the cumulative impulse response will be much higher than in the menu cost with a lot of selection effect, where the kurtosis is equal to 1. Overall, here, this relationship, this theoretical result, and this sufficient statistic theoretical result says that this cumulative impulse response depends on 2 things: the frequency, which is the time for a shock to be transmitted to prices. If it's very quick, you have no real output effect. And another important moment will be the kurtosis that will measure the lack of selection effect. So if you have a lot of selection, firms will adjust their price by a lot, and you will see for a given frequency, firms will adjust by a lot their prices. So it means that they will transmit very quickly the monetary policy shock to their prices. And if there is no selection effect, like in Calvo, you will have very small price adjustment, very large price adjustment, and it will with the lack of selection effect for a given frequency, you will observe a less important output effect for a given monetary policy shock. So this is the intuition behind this result, and this result holds for many models. In a sense that this result will hold in any random menu cost model. So the Calvo Plus model of Nakamura-Steins in 2010, for instance, which is the model under which Alvarez et al. In 2016 obtained this result, but also Golub-Savlak's model, Dot-Thinking-Wallman, also rational inattention models like Woodford 2009, Kostenak of 2011. And also multi-product models like Bonomo et al. Models. Here in this new Alvarez Lippi et al. Paper, they show that this theoretical result will hold in many models with whenever you have this type of Caballero angle random menu cost. This result will hold under in an environment with 3 characteristics. The first one, you need to have a small inflation, okay, no trend inflation in your economy. The result hold if the gap between the optimal price and the actual price closed after the adjustment. So when you adjust to your optimal price, meaning here that you have it doesn't explain the sales prices, promotions, this kind of thing. And the last assumption is the fact that you are in the shocks, the marginal cost shocks are they are Brownian shocks. Okay, so you don't have any leptokurtic, shocks. This kind of unusual assumption for the distribution of shocks. Okay. This is the 3 assumptions under which this result holds. Now, what we do in this paper? Is to explore the empirical validity of this theoretical result which again is very general. So we will try to look at how these results holds in the data. So, and for that, we will exploit the cross-sectional variability in kurtosis, frequency, and cumulative output response. And we will use CPI and PPI French microdata to test this empirical validity. And here, but it might be clear from the formula, there are two empirical challenges. The first one is to have a measure in the cross-sectional dimensions, so sectoral heterogeneity in the response to aggregate monetary policy shocks. And the other challenge is empirical, again, is to measure micro movements of the price change distribution for CPI and PPI. And here the two important moments are frequency and kurtosis. This is on the right-hand side of the sufficient statistic result. So how to test the sufficient statistics? How from the sufficient theoretical result, how do you go to the empirics with this sufficient statistical result? So the first thing to so here, two or three simple equations. The output impulse response function at the given time S will be equal to the monetary policy shock delta minus the response of the price level, okay, for a given sector J. Okay, something very simple. And here we define the cumulated impulse response function outputs and prices as the sum of the impulse response function. And here we know that, or under the sufficient statistic result, the cumulative impulse response function of output is equal to this ratio or depend on the ratio kurtosis over Freg. And we introduce here in the middle of this formula this transformation between the relation between the cumulative impulse response function of output and the cumulative response function of prices. And combining the two, we can show that the cumulative impulse response function of prices will also depend on this ratio kurtosis over Freg. Why going for this cumulative impulse function of prices? For two reasons, basically. The first one is that, as you can see, we don't see this rho J anymore, because here you have rho J on both sides, so, and rho J is the labor elasticity, and here, and it's sector specific. As you can see here, we don't have a rho J anymore, which is more convenient from an empirical point of view, since we don't have a clear measure of rho J. So we remove a measurement issue. Another important aspect is that here, this cumulative impulse response function will be price series, price sectoral series, and on the other side we will have price movements. So in a sense, it's a bit more consistent from the empirical side to measure to test this theory using prices on both sides. Even if it's not the same data set, here are price series, and here we are using micro individual prices. It's a bit more consistent. So the main theoretical prediction to be tested will be this one, where you relate the cumulative impulse response of prices to this ratio, and you see the parameters of interest. The constant here, which is equal to delta times t, so delta times t, if you have a very quick response of prices to the adjustment at day one, you get a full response to prices. So prices will increase by 1% over the time t, and you get this flexible response of prices. Okay, this is exactly what we have here. And here you have the fact that prices won't respond immediately to the monetary policy shock, and this will depend on the times it will take for firms to respond to this shock, and also on the selection effect. And you can go even beyond by with a Taylor expansion around means of F and K. You can decompose this relationship and introduce separately kurtosis and frequency if you want to test these two moments separately in the equation. So this is typically what we want to test. Now, from the empirical test, what we observe this object, the cumulative impulse response of prices, and this ratio of kurtosis over frequency. And these are the two parameters we would like to estimate, alpha and beta. And if you have followed me a little bit on the previous slides, you see that the theory predicts that alpha will be equal to delta times t, and beta is supposed to be equal to minus delta over 6 if the theory is correct. In our setup, we will normalize the shock delta to be equal to -1. Okay, this is a restrictive monetary policy shock that will decrease prices, and this would imply beta equal 1 minus over 6 and alpha equal minus t. And you can do the same with the extended version or unconstrained version of the regressions. And here the theory predicts that beta f will be equal to beta k, or in absolute values equal to delta over 6 k bar over f bar. This is the simple test we propose to run using the data. The empirical strategy will then follow 3 steps. The first one, we would like to measure the effect of monetary policy shock for different sectors. So we will have J sectors, and using a factor augmented VAR, we will estimate the VAR and sectoral time series for French economy to get sector-specific response of prices to a monetary policy shock. This is the left-hand side variable. On the right-hand side, we will use microdata on CPI, PPI for French economy too, and we will calculate the moments of the price trend distribution. And here, two moments are very key here, the frequency of price adjustment and the kurtosis of price adjustment. And then the last step will consist of relating the two across sectors, so product level moments and the cumulative impulse response function. So let me go very quickly through this. So we have micro time series, micro price data. So the step one is pretty standard. We will measure sectoral cumulative impulse response using a factor augmented VAR. We have a matrix of a lot of sectoral price indices, production. We will construct we will extract factors from this X matrix, and we will relate in a standard VAR, the policy rate and our factors, and then we can construct impulse response functions for each of the sector because there is a relation between X and F. The identification is very standard too, in the sense that we use for the baseline results a Cholesky identification strategy, like in the standard favor of Bernanke et al. Paper, and we add a long-term neutrality restriction in the sense that output come back to its original level at long horizon, and all sectoral prices have the same response in the long run. So there is no relative price effect in the long run. And we have other identification schemes. So this is the aggregate response, and this is what we use. Okay, these are the sectoral responses to monetary policy shock, and this we will calculate the cumulative impulse response function, and we will use this data for our OLS regression. On step 2, we calculate the cross-sectional moments on microdata, CPI, PPI, millions of micro price data, and as you can see, we have the frequency here about between 10 and 20%, and a value of kurtosis, the average is 5. But more importantly, we have some heterogeneity across sectors. So here's the distribution of the frequency and kurtosis over the products, and you see there we have some kind of variations across products that we can exploit to test the theory. And now I'm turning to the step 3, which is the key step. This is the test of our theory. So to test our theory, we will run OLS regression relating this cumulative sectoral impulse response function to monetary policy shock to the ratio, curve over FREC, for 2 horizons, 2 years and 3 years. And here you have the results for our baseline favor, the one with Cholesky identification and long-run restriction. So compared to what is the prediction of the model, the prediction is to find a positive and significant effect of the ratio. This is the case. Okay, you see, we find, and for most specifications for PPI, we find this positive relationship between the cumulative impulse response function and the ratio. We also find that the constant is negative for all horizon, all specification. This is also what we expect. Now we can go, so the value change a little bit from a specification to another, but we can also go a little bit further by testing the value, whether beta is really equal to or is not different from 1/6 and alpha not different from -t. And here are the results for this test. And you see, in our baseline scenario, we can't reject this assumption that these coefficients are equal and are in line with the predictions of the theory. Now we can go a little bit further by introducing separately the two moments, kurtosis and frequency, to see how they are correlated to this cumulative impulse response function. And as predicted, the frequency has a negative sign, significant, whereas the kurtosis has a positive and significant effect. Positive and significant correlation. This is also in line with the theory, and the minus and the negative effect. The negative intercept is also it's also what we obtain for all the regressions. Another thing which is interesting here with this unconstrained regression is the fact that these two coefficients are we can't reject that they are the same. And this is typically what is predicted by the sufficient statistic result. Okay, and we can't reject this equality in the two coefficients for all of our specifications. Chiara, I don't know how much time I have left.
2 minutes.
2 minutes?
Yeah.
To go a little bit further, we ran a placebo test of this sufficient statistics. So here the theory predicts that all the moments of the price change distribution shouldn't have any effect on the cumulative impulse response function, especially the odd moments like the mean or the skewness of the price change distribution shouldn't affect shouldn't have a positive effect, or the positive sign or negative sign, or any significant effect on the cumulative impulse function of prices. So we run this test by adding all the moments of the price change distribution, the mean, skewness, standard deviation. As you can see, in all specifications, we don't see any effect of all the moments of the price change distribution, and still we keep the positive and significant effect of the kurtosis over Freck on the cumulative impulse response function. This is another type of evidence in favor of the sufficient statistic result. We have tons of robustness results around this baseline, so I have no time to present all of them, but results are pretty robust to the measurement of kurtosis in particular. So there is a lot of discussions about how to measure exactly the kurtosis, and we find that the result for PPI is really robust to this measurement issue. We also have results for other type of identification. What I would like to say before concluding is that we have also, so we have a lot of results too for CPI. For CPI, it works, but it works a bit less well than for PPI. Results are a bit weaker, especially in our baseline scenario. So for the ratio, as you can see, it's not significant anymore. For other specifications, the result still holds. It holds a little bit better when you use the unconstrained. You can see negative, positive, significant both, and they are not different from each other, which is again in line with the prediction. Here, what we think is that it might be related to the fact that for CPI there are many products where sales play a big role. And when we exclude these products, the food, clothing, furnishing, again, the results we find that the result is a bit more in line with the theory, positive and significant for the ratio, and the same for the two moments taken separately. So overall, what we did here is to try to present a test for the sufficient statistic proposition. So we derive from the sufficient statistic proposition an empirical test, and we test it using the French PPI and CPI data, and we find that overall this sufficient statistic proposition holds in many contexts, especially for PPI, but also to some extent to CPI, and we can't reject that both moments have the same effect in magnitude on the cumulative impulse response function. Thank you very much.
Thank you. When you have two questions by Raphael Schoenle, and I would like to also add my little twist to one of the two questions by Raphael. So one is, what if you add controls to your regression, like fixed effects, and don't you need these controls to claim that you have an empirically sufficient statistics? And if I can add like an appendix to this question, this is what your placebo does, no? Because you put other moments, and those moments, once you consider these two, should be insignificant, and that allows you to say that it's a sufficient statistic. But the placebo, I think, fails often for the CPI regressions, and you have an explanation of the CPI weaker results based mostly on measurement errors, the role of sales. But if it's measurement error, how do you explain that other moments are significant? So shouldn't measurement error make everything kind of not significant? So do you have a story on that? And then I let Raphael maybe ask the other two questions, if you want to take them all together.
Yeah, I can take them all. I will answer to these questions. I have more results, in fact. So on sectoral dummies or other controls, so we have yes, so we have regression results with sectoral fixed effects, and here, as you can see, it weakens the results for sure, because here what is going on when you include sectoral fixed effect, it will capture part of the variability of the cumulative impulse response function, but also of the moments. So you will weaken your relationship, especially the significance of the relationship, especially if part of this variability is coming from broad sectors. So here I included broad sectors fixed effect, but if we think that the result is in the data is coming from big differences between energy and services, I don't know, and here it will. So here, this type of regression in our view is more informative about the source of variations that are useful for the theory. Okay. Here, what we try to do is to try to see which type of variables the theory is supposed to predict. Okay, so here in the theory, in the placebo, there is a theory behind. Okay, there is a theory that in the theory it says that odd movements, mean and skewness shouldn't have any effect on the cumulative impulse response function. So this is pretty clear from the theoretical point of view. So then you can add many controls, but your theory does not predict anything on these other controls. So you need to be quite sure about what you do. So another way to do it would be to add this fixed effect, but as you can see, the results in most specifications still holds. But it's not completely satisfactory to include these dummies, because they will also capture part of the variability which is in your data and which help to test the theory. So it's like removing all the variability and then you don't have anything, but it's not really a proof or any evidence against the theory. It's more like you don't have sufficient variability to test your theory. That's more what I wanted to say. And on placebo, maybe.
On placebo, yeah.
On placebo, we don't have a lot of moments that appear
CPI,
to be significant.
I meant.
Oh, for CPI.
I meant placebo for CPI, yeah, which you didn't show, so but it's in the paper, no?
Yeah. So we have this placebo for the unconstrained. Yes, you have some cases where yes, that's right.
Skewness are significant.
Skewness in particular, but I think in the constraint, the mean too.
The mean also.
Yeah, that's right. But here, the cells doesn't say anything about. So it's more like, again, in the theory, there is no cells, no promotions. So it's hard to say what is supposed to be for all the moments when you have a lot of cells or a lot of promotions. I don't know if I answer your question, Chiara.
And maybe I add yes, and maybe I add also that Raphael also asked how you interpret the high R square for CPI while you have often low R square. I would add for PPI.
No, the R square are basically quite low. Quite low. About, so for CPI here, it's about 5%. In most cases, it's 10%. In unconstrained version, it's a bit higher, because since you taken them separately, you improve the explanatory power of your regression. If you add the sexual controls, it's the same. But generally, they are not very big. They are not very big.
Yeah. I'm afraid we need to move on, but you have many questions. You know what I'll do? Can somebody from the audience, so I understand how this Zoom works, ask a question in the Q&A to say if you now see some of the questions, because I think I put some so that they become visible. Because in this case, I will move them all to that, and then I will copy and share with everybody in the panel. So at least the conversation continues. Yeah, but in the meanwhile, we maybe move to the next paper by Peter.
Thanks. Can you please confirm that you see the slides? Thanks a lot. So it's great to be here, and thanks for the organizers for putting the paper in the program. It is joint work with Raphael, who's in the audience, and Jesse Wursten. The usual disclaimer applies. So our motivation for this paper is actually very similar to the motivation of the previous paper, so that the rigidity of the aggregate price level influences the real effects of monetary policy, as well as amplification through demand type channels. And if prices, we know that prices change infrequently, and in standard price setting model, this means that the price level is rigid. But in models which are microfunded by fixed cost of adjustment, like Golub and Lucas 2007 model, the price level can stay flexible even if only a small fraction adjusts, and the reason is kind of price selection, that it's large prices that are going to be endogenously selected. And why is this the case? it's because if you have fixed cost of adjustment, it's going to be optimal for you to concentrate on the most mispriced products. And when an aggregate shock hits, the adjusted prices are going to be the ones that are most mispriced. Then they change by a lot, and this is going to raise the flexibility of the price level. So what is it we do in this paper? So we are going to revisit the Golub and Lucas critique to price rigidity by establishing some new facts using microdata. So what we are doing is we are generating some proxies for the level of mispricing in microdata. So the measure of some measures of price gaps. We are going to identify aggregate shocks and going to measure selection as the impact of the interaction between the price gap and the aggregate shock. So this is a kind of micro-macro interaction on the price change probability. So again, our prices is that are the prices which have large gaps are changed with higher probability than those which have low gaps condition on the shock. So what is it we are going to find? So we actually find evidence for state dependence. So actually both at the micro and the macro level. So on the micro level, we find that both the price change probability and the price change size increases with the gap. But importantly, we find that in aggregate, there is no selection in a particular sense. So the gap is immaterial with respect to the aggregate shock. And instead, what we find in the macro level is that there is a state-dependent adjustment, but it's going through the gross extensive margin, which we define it as a shift between the frequency of increases versus decreases. But we don't call this selection because this is uniform across the gaps. So it's not uniform between increases versus decreases, but uniform across the gaps. So we think that these results provides extra guidance for model choice and policy implications. We argue that these results are consistent with mildly state-dependent models. For example, the Woodford model with information frictions and sizable monetary non-neutrality. So let me just quickly give you a sketch of the theory, what we are after, and how can we kind of intuitively look at the effects in a discrete time version of a price adjustment model. So the setup is similar to what was previously. So there are price adjustment frictions, which makes the price adjustment lumpy. And an important state variable is the price gap. So the difference between the price, so it's in log levels, relative to an optimal price that would be set if the price adjustment frictions were not present. And so in this framework, the price is going to adjust occasionally because of the adjustment frictions, while the optimal price is going to change continuously by both product level and aggregate factors, and this will, in the cross section, will generate a dispersed distribution like the one which is illustrated in this figure. So the focus of the effect of the selection effect and because of this R focus is also the shape of the adjustment hazard. In a fixed menu cost model, so SS type model, it's a step function. So for low levels of gaps, the probability of adjustment is 0, and after a threshold, the probability of adjustment becomes 1. So it's a step function. Together, they are going to generate a price change distribution, and in this SS model, actually the price changes are going to be large in normal times. Importantly, this is not what we call selection. So this is basically just normal time large price changes. Instead, what we call selection is the position of new adjusters after an aggregate shock. So here there is an aggregate shock hitting, which is going to shift the the hazard to the left in this setup, and there are going to be new adjusters, and basically the position of the new adjusters is going to influence how much the aggregate price level is going to be, how flexible the aggregate price level is going to be here. Because the new adjusters are far from their optimum, they are going to change their prices by a large amount, and there is going to be large selection. In contrast, in a Cavo model, the hazard is flat. There are going to be so new adjusters are not going to be. So basically, there are going to be no new adjusters. The adjusters are going to distribute similarly. There is going to be no selection there. So Golub and Lucas shows that it's very also as others as since and also before that it matters a lot. So in a menu cost model, the real effects of a monetary shock is much smaller and less persistent than in a Cavo model, where it's larger and more persistent. So what do we do so what kind of data we are using? So we our baseline, we are using supermarket scanner data, but we also show that our results is robust to the US PPI in the paper. So we like the supermarket scanner data because of two things. So one is it's really granular, so it really has unsurpassable quality information about close substitutes. These are basically barcode level data. So when we are comparing close substitutes, we are talking about exactly the same products in other stores. And on the other hand, it also has fairly long time series, so we can identify aggregate fluctuations. It has already been mentioned in the previous presentation. Our theory is not about sales, so we actually look at reference prices, of filter out temporary discounts, and we also do some time aggregation. So the data is originally weekly. We take monthly data as the monthly mode of the weekly prices. So this is what our sample works compared to a subsect, so sectoral inflation rate in the CPI. So this is the orange line that shows the CPI food at home, and the blue line shows our price index. You can see that we are very good at matching the fluctuations in this price index. We are actually not perfect in matching the levels, and this is mainly due to us not linking similar products over time when there's a new price introduction, while actually statistical institutes put a lot of effort into that. But this is not that important for us, because our question is really about conditional responses and kind of business cycle fluctuations, where, as I said, we are very good. So our point in the paper is that we think that even though the price gap itself is not observable, there is a relevant component of the gap, which is, and we measure this as a distance from the average price of close competitors, if after controlling for store fixed effects. Store fixed effects are going to control for kind of regional variations and amenities that introduce permanent differences in price levels. And the idea is that stores want no mispricing, so they don't like when their prices are above the average of the competitors, because then they face low demand, but they don't like it when it's lower either, because then their markup is too low, so they can increase their profitability by increasing their prices. So this is just formally what I said. This is how we define the price gap empirically. In our specifications, we are going to use the lagged gap, so gap before the aggregate shock hits. In this sense, this is going to be a measure of initial mispricing, not kind of the actual mispricing, which is actually in Luca's Luca Detola's recent work, the focus of the paper. So this is how the distribution looks like in our data. So we see that there is a sizable dispersion, even though we are doing both sales filtering and store fixed effect, and as well as we have quite fat tails of the gap distribution. If we look at the size of price changes conditional on the gap, on average, we see that we have a very close to one, inverse one-to-one relationship between the size and the gap, which is an indication that we are actually measuring a relevant component of the gap. So when the firms decide to change their prices, they actually close the gap on average. On the other, we can actually look at the frequency of the price adjustment as a function of the gap. We find that it actually has a kind of a familiar V-shaped distribution. So it's positive at zero, but it increases with the distance from zero. It's asymmetric in the sense that the probability of price adjustment is higher when the gap is negative. So when the price is below the competitor's prices, and then when it's positive. And also we like to point out that actually in the relevant margin, so in the region where most of the price gaps are, it is actually close to linear, close to piecewise linear, and actually it becomes even more linear when we are controlling for unobserved heterogeneity, as I can show you later in the presentation. So when so now we have the gap. So now we need an aggregate shock. What we use as a baseline is a credit shock. It's a exogenous tightening of the credit conditions identified using time restrictions. But actually, in the paper we also use monetary policy shocks, and our results are robust to that. So just to show you how the impulse response to this credit shock in our sample period looks like, let me show you just local projections, so standard local projections, regressions of this excess bond premium shock, where for contemporaneous controls we use CPI industrial production 1 year, monetary policy, 1 year treasury rate, and then so all the legs of all of them. So this is these are the local projection input responses. It shows that for excess bond premium tightening, so credit shock, the excess bond premium tightens for kind of less than a year. The monetary policy eases, but it's not sufficient to offset the effects on activity, and there is a persistent decrease in the core CPI, which peaks around 2 years after the shock. If we do the same thing for our supermarket price level, we see a very similar picture. So there is a gradual response to the shock, and the peak effect is not before these 2 years. And actually, this is what we are going to use as our reference period. So now we have both the aggregate shocks and the proxies. We are going to now we can access selection. So our question is as looking at selection as an interaction of the aggregate shock and the product level proxy in a linear probability of model of price adjustment. So this is our baseline linear probability model. So the dependent variable are separately the price for price increases and price decreases are indicators whether there was one of them for a product in a particular store between a current period and the period 24 months into the future. And then for our main variables, so we are including the aggregate shock directly. So what's the effect of the shock? What's the effect of the gap? As I said, lagged before the aggregate shock hits, and their interaction. And our focus is really the interaction term. So is it true that when the aggregate shock hits, those that are further from the optimum, so those which have larger gaps, are adjusting with higher probability than the others. We also include a lot of controls into our regression. So we have age of the price to control for some of the time dependence. In the paper, we have a lot of aggregate controls as actually the same aggregate controls that I mentioned before in our local projections regressions, and we also satiate the regressions with fixed effects, so product store fixed effects, as well as calendar months fixed effects to control for both cross-sectional heterogeneity and seasonality.
You have 3 minutes.
Thanks a lot.
3 minutes. Huh?
Yeah. So these are the main results of the paper. So what you see here is that, so in the left column you see the price increases, the right column you see the price decreases. We see that the price gap is always significant with kind of the expected sign. So the larger the gap, so then the probability of a price decrease is lower, probability of price decrease is higher. When the aggregate shock hits, we also see that there is a significant effect on the probability of price increase and probability of price decrease. But what we see, and this is what we find consistently in various robustness checks, is that the interaction is never or almost never becomes significant. So how we interpret this is that what we see is that there is say dependence in the aggregate. So there is a uniform shift between price increases and decreases when the aggregate shock hits, but this is independent of the gap itself. So as this is basically what I said before. So there is state dependence. The gap raises the frequency, but the adjustment is happening at the gross extensive margin, and there is no selection. So one worry you can have is that we impose linearity of the effects. Here, what we show is that this is not very restrictive. If we, instead of imposing linearity, we create groups and look at the effects of the groups. On the one hand, we find that the direct effects are significant and kind of close to linear. And we find that the selection effects of the interaction terms, which is the blue line, are almost never significant except at one point. And we also have a battery of robustness checks in the paper. And if you have questions, I can go over them. So just to interpret how these results can be kind of explained in a kind of illustrative framework, we argue that if you have a model with kind of random menu cost or the framework with linear and flat hazard, then the results can be consistent with this. In particular, if you have this kind of linear hazard function, if there is an aggregate shock, it's going to create a shift in the hazard function as before, but what it's going to generate is a shift in the probability of price adjustment, but that's going to be uniform across the gap distribution. So this is going to have basically no selection because the new decreases are going to be dispersed across the price change distribution. So this is showing in the table what I mentioned. So what we argue in the data is that there is evidence for the gross extensive margin and evidence for no selection, and this is inconsistent with time-dependent models where there is no extensive margin effect, so no either gross extensive or selection, but it's also inconsistent with SS type models or models with strongly convex hazard functions, because then you have both. You have gross extensive margin as well as selection. And what we argue that with linear or close to linear hazards, the results are consistent with what we find. So I don't have time to talk through the literature. So let me just conclude. So so we use granular supermarket data as well as PPI data to measure selection. We find evidence for state dependence, both at the micro and the macro level, but evidence for no evidence for selections. And we argue that this is inconsistent with standard time dependent or state dependent SS type models, but consistent with mildly state dependent models like information constraint type models of Woodford, especially with linear and flat hazards, which imply sizable monostory non-neutrality. Thanks a lot. Looking forward to your questions.
Thank you. You already have a question from Francesco Lippi about non-linearity and using the local probability model. I can read it off and then you answer. So Francesco does not understand the ratio of the test, because why do you use a linear probability model to test a theory that is nonlinear? And then how can you expect a significant coefficient of the interaction if the true model is nonlinear?
Yeah. So I think our answer is that we have a version where we don't impose this linearity. And I think I hope this kind of answers this. So instead of assuming that the relationship between the gap and the aggregate effects is linear, here we are kind of creating groups and we allow the effects to vary and potentially be nonlinear. And in what we find here is that the effects are kind of close to linear. So we argue that and the aggregate effects are consistent with our kind of linear probability model. So I think it's a very important question. So what we think is that the data justifies our choice.
Any other questions or reaction? I don't see in the Q&A. I have one question, if nobody else has one, which is that basically my understanding is you start from non-theoretical statistics and then you land on models that are compatible with your observation, which are basically random menu costs or rational inattention. So we will see also in the next presentation how rational inattention is linked to low inflation. So how important do you think is the fact that you are looking at a period of low inflation for your result? Do you think it can be important? What would happen if you had, what would you expect if we were in a higher inflation regime? Did you think about it?
Yes, so I think it's potentially important. In some sense, so we think that it's true that our moments are kind of at theoretical, but I think they are kind of well justified by theory. And what I showed here as a baseline, here we are taking the distance from an average price, and that can be far from the optimal price if the inflation is higher. So in that sense, then the gap or gap measure that I showed you as a baseline is going to be worse and worse. But if in the paper we also show another gap measure where instead we look at the average price of only those who are actually changed their price. So that's kind of a competitor's reset price, which is in quite a few models. This is the valid price. So if these firms who are changing are actually setting their price optimally, they are going to. So this is what we are going to measure, and then even if there is inflation, we will have a kind of correct measure of the price gaps, and our results are actually going through. So there one of the issue is that we need to have a lot of observations to be able to choose just those that are changing. But actually, luckily in this scanner data, you do have it. And but yeah, on the other hand, for BPI data, this is not something we can do because there's also quality differences and not enough close substitutes where we can do. So basically that justifies our choice as a baseline, where I think you are, as you pointed out, low inflation is kind of a necessary condition for these gaps to be good proxies.
Okay. I see no other questions from you, so just in time we can move maybe to the next presentation. Thank you.
Thank you.
All right, thank you. Can you guys all hear me and see my slides?
Yeah.
Fantastic. So first, I think this has been a remarkable conference. I'm honored to be a part of it. Thank you very much. Thanks to the ECB for organizing this session, and thank you, Chiara, for chairing it. So I want to talk about inflation expectations today, but I'm going to do it from a different point of view. Probably not likely, not a point of view that you've maybe encountered before. So I'm going to need you all to kind of suspend your disbelief for the next maybe 19 minutes or so, and then you can let me have it at the end. So my argument here is really, it's quite simple. The argument is that we really need, in this environment here, at least in the US, we need to take a different approach to eliciting inflation expectations or expectations on the nominal side of the economy than we've been taking. So for example, let's look at just the conversation around inflation expectations that we've already had so far in this conference. It started off with Ben Bernanke mentioning the board's new common inflation expectation measure. It's sort of a composite measure. The reason you'd need this is, the current measures that we have, especially on the survey side, they all have idiosyncrasies and things that are not necessarily giving us really strong signals of inflation expectations. So we need this sort of, composite approach. And then we heard from Hassan Afrouzi, and he talked to us about the importance of really getting informed individuals and measuring their expectations, because it's the expectations of the informed individuals that matter. And then there was this stellar experiment from Martin Kantz looking at how information on inflation expectations, aggregate beliefs, changed spending, credit card spending among households. And it turned out that, what you see is it's changing beliefs, but it's not necessarily changing behavior, right? So the question is, well, what's going on there? Are these things relevant? For households. Let's Killian talk to us about oil prices and how, whether or not they're important to household inflation expectations, or periodically important, or, whether or not household inflation expectations actually co-vary with oil. I thought that was very interesting too. Jan Tuzinski had a fantastic paper, dealing with looking at how individual household behaviors really match up and matter for their inflation expectations. And honestly, in that session, I don't know if you guys all attended, there was this cathartic sort of discussion, or at least cathartic for me, about all these sort of issues that we have with the current state of survey inflation expectations measures. And that list doesn't even include today's speakers like Elena and Emmanuel talking about some of these issues. So that kind of brings me to my main point. at least in the U.S., and maybe if we had well-informed economic actors like it appears Germany does, this wouldn't be maybe as big of an issue. But at least in the U.S., it appears that price stability has been, in effect for quite some time. So much so that notions of prices overall in the economy or notions of aggregate inflation don't necessarily move the needle for economic actors, be it firms or households. And in a Greenspan version, this is really a notion of anchoring of expectations. It's basically these things no longer matter. Well, okay, so if that's true, and maybe that's true for a large subset of actors in the economy, how do we measure the nominal expectations? How do we then track to see whether or not they're becoming unanchored? Is it just that we start to get answers that from some of these current measures that come closer to what actual inflation? It's not entirely clear to me. And the other thing is that when we're talking about a lot of these measures of aggregate inflation, you find that there's certain salient prices or certain prices in the basket that matter more to individuals than others. For example, one thing that we've seen, I think, since the onset of first 3 to 4 months of the coronavirus here in the U.S., we saw a dramatic increase in food grocery store prices. In fact, they comprise the entire upper tail of the price change distribution. It was it was the top, anything that was really, that top 5% of the overall CPI distribution by expenditure shares. That was food prices. And what we saw inflation expectations, or at least on the part of households, jump markedly right there. Well, we're calling these things inflation expectations, but if in fact firms or households are responding to a relative price change, and they're giving you an expectation that is a relative price, it becomes a bit more challenging to use that to draw an inference on whether or not these things are anchored or how individuals are responding to policy communication. So really what I think this is motivating for us is trying to get at a different way in a low inflation environment to measure an inflation expectation. And so we've seen these questions a lot. Why do firms and households hold these aggregate inflation expectations that appear disconnected from reality? And in some sense, I want to argue that this is maybe the wrong question to ask in light of rational inattention, in light of the fact that inflation, at least until very recently, has been low and stable in the US. What I want to ask is there a measure of price growth that's both relevant to at least firms in this sense, but it's relevant to the economic actors, and here it's firms, and connected to measures of actual inflation that we tend to follow, aggregate official price statistics? And my answer here is yeah. The price growth that's associated with firm-specific unit cost growth is the appropriate. It is a good lens into the nominal expectations of businesses. Hence, it's a good lens into their inflation expectations in mass. And I want to kind of cut to the chase just so we can see this right up front. What we're looking at right here is the relationship between firms' realized inflation over the past year, so their year-over-year unit cost growth, versus measured aggregate inflation. And here I'm plotting the GDP price deflator on a year-over-year basis. These are quarterly aggregates of our survey. This is very highly correlated. So firms' unit cost perceptions or realizations, their understanding of the nominal side of the economy, Well, it matches what we track when we're talking about inflation. It's very highly correlated with the broadest measure of aggregate inflation, this price GDP price deflator. And on top of that, if we measure inflation expectations this way, we get a measure of unit cost expectations, or 1 year ahead unit cost expectations of firms, or inflation expectations of firms, that is very highly correlated with professionals. So here I'm plotting our measure aggregated quarterly versus the survey of professional forecasters 1 year ahead GDP deflator expectations. I just kind of want that to sink in a little bit. So while these aggregate notions of inflation, may be really disconnected, when you ask a firm something that matters to them, something they're paying attention to, something that's relevant, they're giving us back things that are relevant to their own firm. And when we aggregate those things up, we get a measure that looks like a valid inflation expectation to me. So that's really, the long and short of what we're doing in this paper. The short answer to this sort of first question I posed, this puzzle over aggregate inflation expectations, and I think the literature, and again, what we saw so far in this conference, economic actors, and most of the focus has been on households, they put very little weight on understanding and tracking aggregate inflation measures. In a low inflation environment, this is maybe what we'd expect. And if you were Alan Greenspan, this is your central banker, maybe this is what you really want. Maybe this means that you've achieved price stability. Now, the longer answer here is that due to the lack of relevance that firms place on these aggregate measures, trying to get at what their expectations for the nominal side of the economy or their inflation expectations requires asking a different question. In this sense, or in this way, we focus on that lens of unit costs. And by unit cost, I mean expectations. I mean own firm nominal marginal cost expectations. Unit cost is a term that when we did cognitive interviewing resonates with firms and aligns closely to what we would consider a nominal marginal cost expectation. By aggregating these own disparate firm-specific unit costs and their expectations, we can uncover relevant inflation expectations for firms. So supporting evidence for this argument is really on a micro level. Firms actually pay attention to this. They report planning frequently around unit cost changes. They report, that unit cost changes influence their own price changes. We show this. And on a macro level, we see what those two slides I just showed you. Basically, that their unit cost realizations match overall aggregate inflation statistics, and unit cost expectations, when we've aggregated across firms, looks a lot like professional forecasters' expectations. So in this paper, and I'm going to kind of run through this quickly because I think I only got about 8 minutes left. We contribute to the literature on rational inattention and basically say, if we're in this low inflation environment, we need something that, and economic actors have stopped paying attention to things that we might want them as economists to pay attention to or as central bankers to pay attention to. They've stopped doing that. We need to figure out another way to engage on something that is going to give a monetary policy insight into the forward nominal expectations of economic actors. And for firms, we think that's unit costs. And we contribute a bit to the literature on New Keynesian theory, or at least taking the micro foundations of the New Keynesian Phillips curve and really testing whether or not you can ask whether or not nominal marginal forward nominal marginal costs are really the driving variable, and at least in our evidence, it appears that that's the case. Now, there's a couple other areas of survey literature, I think, in economics that are well known outside, but people, at least in the economics profession, tend to miss a couple of these things. So there's a lot of literature on trying to avoid asking questions that don't apply, that aren't relevant to respondents. In the survey world. And the other thing, and this is social desirability bias, and I'll be 100% honest, there are some questions that we've asked in the past that violate this tenet. But basically, the argument is that coming out of the survey literature is respondents try not to reveal their lack of familiarity, is maybe the best way to put that with a concept. They assume that, you know, if a researcher or an economist is asking them a question, it's something that they ought to have an answer to. So for us, we did a lot of work on cognitive interviewing and talking and chatting with business decision makers, CFOs, small business owners to try to figure out, you know, what things matter before posing that in a survey. And here we find, at least in this low inflation environment, that what's relevant is unit costs. So there are a couple other things, and I'm not really going to show you any of our evidence here, but one thing that we do, our inflation expectations are probabilistic. We ask them in a probabilistic format, following Mansky and Engelberg and some of these other folks. It actually a similar bins approach that the New York Fed has. And then we can take our probability distributions. What we do is we'll trace out a parametric distribution instead of just taking the unparametric approach, you know, the midpoints of these bins and you know, multiplying through. And the approach that we take is this, it allows for bimodality. So it's a bimodal asymmetric power normal distribution. And that has a lot of flexibility, and it allows for firms that would give you a sort of scenario-based forecasts. So, you know, if, you know, something around whether or not labor markets break one way or the other here, more recently, a firm might give us expectations that are bimodal or that are missing mass in between a couple of bins. And in parametric estimators, it's really tough for them to handle. We've adopted this bimodal asymmetric power normal distribution to try to fit those distributions a bit more closely.
Brent,
so,
5 minutes.
Yes. Sorry. 5 minutes?
Yep.
All right.
Yep.
So let me try and speed this up. You know, it's a survey of about 500 C-suite execs in the Fed's 6th district, which is pretty much all of the Southeast U.S. It's not statistically random, but the 6th district has nice size and industry characteristics that are close to the true U.S. Distribution of firms. And we sample in a way that tries to match the size and industry characteristics of these firms. Again, we ask these questions in a probabilistic way, and we've been around since October of 2011. And again, the rationale for our approach, you know, why unit costs? And again, in theory, the forward path of marginal costs drives the pricing decisions of firms. So here's a quick snapshot of what the probabilistic questions look like. And, you know, and firms in our panel get this, you know, monthly. This is a monthly core question. It's a bins and balls type approach, where you're filling out probabilities to predefined bins. There's really 3 unique features of the BIE. It's the focus on own firm unit costs, asking these in a probabilistic way, and we have a panel structure. I'm going to skip the representative stuff. I want to skip some of this stuff because I'm running out of time here too. But basically, a couple of key features of the data that you would want to see, at least on a micro level, to have some confidence in what you're doing is whether or not the expectations are related to outcomes, and whether or not, uncertainty is related to larger ex ante uncertainty is related to larger ex post forecast errors. And we find that it is. The other thing that's kind of interesting, and this speaks to the general literature, is it's typically the case when you pose questions that elicit an aggregate inflation expectation and then include the phrase like measured by the CPI, there's a strong conditioning effect or a tenure effect that happens in these surveys. Basically, people that, well, my interpretation is people that are filling out these surveys go, oh man, they're asking about CPI. I better go find out what this thing looks like. We don't see that with unit costs. Again, I take this, my interpretation is unit costs are valid, they're relevant. They're something that firms pay attention to. Unit cost expectations related to their price changes. And we've done some work, and again, maybe violating some social desirability bias issues that I mentioned. But we did some work early on trying to figure out, what mattered for firms' decision making. We asked a University of Michigan type question in September 2014. We got a University of Michigan type answer. Household type answer. And we followed that up the next month with the consumer survey of professional forecasters type question on the core probabilistic core CPI inflation expectations. And we got a professional forecaster type answer to that question. What really our takeaways from this is really on this slide is a follow-up question that we asked then and we ask again in September of 2015. So what matters when to your business decisions? What matters to your pricing decisions? For business decisions, the overall rate of inflation for most firms doesn't really matter. What matters is unit cost is significant. When we're looking at pricing decisions, again, aggregate inflation or inflation like measured like CPI measures tend not to matter for firms, and what matters are unit costs. Unfortunately, maybe at the moment, monetary policymakers' inflation projections don't really influence unit cost or price forecasts. And then the aggregate inflations aren't correlated with firm-specific measures. And here's, I'll leave you again with just these slides. We take own firm unit costs, and these are realizations. They differ across industry. When you aggregate these things up, you get something that looks like the aggregate economy. For expectations, again, we aggregate, they look different across industry and within industry. For some firms, they look different. You aggregate this up, you get something that looks like professional forecasters' expectations. And I'll stop right there. So thank you.
Thank you, Brent. You have a question from Luca De Dola. Do you want to read it off and maybe answer live?
Sure.
Q&A. Sorry, between chat and Q&A.
Oh yeah, so yeah. I think the new Keynesian model predicts that firms only care about own marginal costs as a first order approximation. Their perceived demand depends on other firms' prices, or in general that there is no strategic complementarities. How do we take your results as ejecting the latter? Luca, this is a fantastic question. We really haven't done a whole lot of work looking at competitors' prices. We've asked maybe one or two special questions about competitor prices. I think that, from what I remember from those special questions, firms do pay attention to other competitors' prices. It might be something that's embedded into their own cost expectations. And then there's a couple other, places you might be able to maybe critique us on using the forward nominal marginal cost, because again, that's in a micro sense. When you aggregate this up and you're using the sort of aggregate Phillips curve, that becomes two components, right? That becomes the output gap basically, and an aggregate inflation expectation that's common to all actors, right? So in this sense, the way that I would answer that is it's a fantastic question. It's not something that we've really dug too far into, except to say that basically what would be moving that around would be the sort of the influence of output gap on prices. And what we've seen so far, at least in our evidence in aggregate, and what we've seen over this time period is that the Phillips curve is pretty darn flat. So, that would be my response there. But that's a fantastic question. So thank you.
Erwan also has a question. Maybe he can ask it live. Yeah.
Yes, I can do it on live. Quick reaction and quick question. So just to share my experience, since we are running now a firm expectation survey too at the Banque de France, and we run some questions where we ask firms about inflation in different ways, and we find unexpectedly maybe that firms don't have so much difficulty answering inflation at the aggregate level. So a lot of firms are able to answer. One difficulty they have is to answer something out of the firm. So to have some perspective out of the firm when you ask them something that is not really in their firm. And my question would be, why not asking them like aggregate unit cost or aggregate wages? I don't see why you don't try to test this, like to test aggregate perspective versus micro perspective, because to some extent, what is interesting is this aggregate perspective of firms. Maybe they don't care about unemployment, GDP at the aggregate too. I mean, it's maybe not only a question of inflation, but just a question of what I think about out of my firm.
Sure, Juan, that's a good idea. We've done a little bit of this. Concepts like interest rates, or at least long-term interest rates, seem to be, or the unemployment rate is another one that we've asked in a special question that firms are able to get. What really I think is imperative on the part of economic or economists when you're digging into these and we're asking these sorts of questions of firms is trying to get at things that are relevant. So it's we were able to ask some aggregate inflation expectation questions if you clue them into the fact that you're asking about the CPI. Sure, a lot of them are able to do it. I would ask a follow-up that says, well, how important are these things? Or do you, maybe a leading question about, do you follow the CPI, or is it important, or are you aware of this before you go and ask that question of firms? But what we find is that these sort of aggregate notions, at least when it comes to their forward nominal marginal cost, this sort of aggregate inflation notion, it doesn't matter for them. It's not it's not influencing their price setting behavior. So anyway, thank you. That's a great point.
I also have a question,
mm-hmm.
which is basically you have a cognitive basis. No, you're saying these firms can answer on things that are important for them, so they know about them. And you also find that once you aggregate them, these correlate with survey professional forecasters and with market-based expectations, mm-hmm. but not with those of consumers. So is there also a cognitive story behind consumer surveys of expectations? But what would be the question you could ask to elicit what matters to them? That's much more complicated, I find. Right?
It's much more complicated, especially if you're trying to get something that is an aggregate notion, that matches an official price statistic. Honestly, this is part of the reason why we're asking firms about something that's relevant to them and not households, because it's a tough thing to ask. I'm not 100% sure how you would go about doing that, other than really conditioning on a very selected sample that follows aggregate inflation, and they pay attention to it, and they actually respond, and they make meaningful consumption decisions based on aggregate inflation. And I think that at least where we're at in the literature, or where we're at in this conference even, is that's tough to do. So anyway, thank you all for your attention. I really appreciate it. Thanks for the questions.
Thank you. Thanks a lot. So we go to the last paper presentation.
Okay, can you see the slides? I suppose yes.
Yes, yes.
Perfect. Yeah, thanks a lot for having me. This is joint work with Luca Di Dola and Chiara Osbat of the ECB, and the title is Tax Thy Neighbor, Corporate Tax Pass-Through into Downstream Retail Prices in a Monetary Union. So what we do in this paper in a nutshell is that we estimate the effect of corporate taxes on retail prices in Germany. Corporate taxes have recently been widely discussed again because Joe Biden has proposed higher corporate tax rates in the US, and Janet Yellen has expressed support for global minimum tax rates. And this is also on the agenda of today's meeting of the G20 finance ministers. Janet Yellen is arguing corporate tax rate, a global minimum corporate tax rate is good to sort of spur innovation, growth, and prosperity in the global economy. But a key issue in the economic analysis of corporate tax rates is the question, who bears the burden of corporate tax rates? And if you look at the academic and public discussion, then you see that this revolves mainly about whether the burden is borne by capital owners or by workers. Okay, so looking at the theory, the burden falls on capital owners if capital is not mobile, but as soon as it becomes mobile, so as soon as you are in a small open economy, it falls, the burden falls on labor. Or if we could look at the conventional wisdom, if we ask different people, then, for example, in general surveys, most people would answer that the burden falls on capital owners, while if you ask business lobbyists, then interestingly, they would warn that the burden might really fall on labor. And if you ask economists, then you see some disagreement, or many take a middle ground. Okay, but as you might have noticed, there's a third group missing from these considerations, namely the group of consumers. And it's plausible that when firms have to pay higher tax rates, that they would then increase consumer prices, and hence the burden would be borne by consumers, in fact. So this is kind of what we want to do in this paper, to fill this gap in the literature by building a model of retailers and tax production firms, and by estimating empirically the effect of corporate taxes on consumer prices, to see if this is the case that as I said, consumers kind of are also hit by increased corporate taxes. Okay. So the contribution in particular is going to be first theoretical. We're going to write down a model that has manufacturers that have some price setting power, as well as retailers, as a conceptual framework to kind of show how a tax on manufacturers' profits would then be passed on to retail prices in the end. And then we're going to do an empirical exercise that exploits around 1,000 changes in the local corporate tax rate in Germany. Based on this variation in corporate taxes, we find that a 1 percentage point hike in the corporate tax rate would raise retail prices by approximately 0.5%, which is quite a sizable pass-through. And this implies that production firms have substantial price setting powers. It also shows that tax shocks propagate abroad, in the sense that increasing tax rate in a given small local region in Germany would increase retail prices all over Germany, wherever these products are sold. In other words, there's a substantial relative price adjustment to local shocks in a highly integrated monetary union that is Germany in our case. I want to briefly link this to the literature. So there is one paper that looks at the effects of corporate taxes in Germany on wages. This is the paper by Clemens Hüst, by Andreas Pechter and Sebastian Ziegloff in the AR. They find that when tax rates go up, then wages actually fall. And what we do in this paper is that we borrow their identification strategy and sort of do the complementary exercise that looks at how consumer prices respond to the same tax rate changes that they consider. We relate to a second paper that looks at the effects of corporate taxes to retail prices, but they look at state level corporate taxes in the US. This is the paper by Baker and co-authors. Relative to their paper, we have much more granular variation in the corporate tax rate because our variation is at the municipality level and not at the state level. So this makes it easier for us to control for other factors such as local business cycles. And the second advantage is that in our case, the tax rate is the only fiscal policy instrument that is at disposal for the policymaker, because in Germany, municipalities really can only set tax rates. And in that sense, whatever we find in association to tax changes can kind of only be the effect of these tax changes and not the effect of another instrument that was simultaneously adjusted. And last, we link to a literature that analyzes price setting in vertical interactions. In particular, we show that in the vertical interaction with retailers, producers have substantial price setting power. Okay, so the conceptual framework or the small model that we set up looks as follows. We have a model of firms that have market power. They're going to be retailers, and they're going to be multiple sales regions into which these single production firms are going to sell their products. Okay, so there are many local markets which we denote by M, and in each local market there's a retailer that sort of buys the production good from the manufacturer and then sells it to consumers, and the retail price is going to be P, M, I, J. So M for the local market, I for the product, and J for the sector or industry or product category to which this product belongs. And the retailer faces a marginal cost that is a sum of two components, namely the wholesale price that is set by the production firm as well as the retail cost. Okay, so the retail cost is something like the rent for the store, other operating costs, or the wages of the cashiers and so on. Given this marginal cost, the retailer is assumed to face a CES demand function with some elasticity rho, and then the retail price is essentially a markup depending on the elasticity over the marginal cost, which is the wholesale price plus the retail cost. Okay, so essentially what we're going to see in the data is the retail prices, and from this analysis we see that for retail prices it matters how the wholesale price looks like, and this is what I'm going to analyze in the next slide, because the wholesale price is the price of the producer that is sort of taxed. Okay, so the manufacturing firm I produces product I. Okay, it's located in one particular region, but it sells to any other region M, as sort of in the application for Germany that we have in mind. And this manufacturing firm has net of tax profits that look as follows. So the revenue that the firm generates comes from selling a quantity Y IJM. So this is the quantity of its product that it sells to that outside market M, and it charges a particular wholesale price Q IM. Okay, so this is the revenue that the firm generates, and this is taxed. So only a fraction 1 minus tau is left after taxation. But importantly, parts of the costs are deductible from the tax payments. For simplicity, we just say that the labor cost is going to be deductible, which is why it's inside this bracket that's multiplied by the net of tax factor. In contrast, there are other types of costs here, for simplicity, the capital costs that are not deductible from the tax. Then we say that all this output that is produced and sold to all these markets M is going to be produced by a single Cobb-Douglas production function or any other production function. But this essentially implies that the marginal cost is common across markets, which leads to the following formula for the optimal wholesale price, which is going to be the marginal cost from producing 1 unit of the good, scaled by the net of tax factor and then marked up by a markup that depends on the demand elasticity, which is in the presence of the retail of the retailer, a function of the wholesale price itself. But this is how essentially a tax change would then feed into the wholesale price. And now, as we know, now know the wholesale price, we can plug it into the retail price. Okay, so this was the retail price P. It consisted of the marginal cost. That's the the wholesale price plus the distribution cost. Okay, so now we see how the net of tax factor goes into the wholesale price and then is shows up in the retail price. We can then take the total differential of the log retail price with respect to the log net of tax factor and derive this animal here, okay, which shows you the pass-through of a tax to the retail price, in the sense that this shows that when the net of tax factor goes up by 1%, then the retail price will go up by this much. Okay, so what we want to take away from this for now is that generally a tax increase leads to a retail price increase, because you essentially see that this thing is something that is bigger than zero. Quantitatively, you can kind of analyze how this depends on the distribution cost, on the share of deductible inputs, and so on and so on. But this is not sort of what we do. What we want to do now, it's just to show how, in principle, a tax increase will feed into a retail price. And now the next step is going to be to estimate this quantity empirically and see whether it's actually bigger than zero. Okay, for this, we need to talk about the data and the institutional setting. So the institutional setting is the following feature of the German tax system. In Germany, the corporate tax is collected by municipalities, so by very small regions like cities across Germany, and these have at their disposal, in terms of a policy instrument, the so-called local business tax. And this business tax is essentially set at the municipality, in particular in the following way. So the tax rate that a firm has to pay is going to be 3.5%, which is a federal base level, which then can be more or less arbitrarily scaled by the municipality. Okay, so the municipality sets what is called a local scaling factor, and thereby it can define how large the corporate tax rate is going to be. And hence, due to the fact that every municipality does this on its own, and also every municipality can decide on this every year again, such that the new tax becomes effective on the next 1st January, we have first geographical variation across municipalities, and within municipality variation over time, which is what we want to exploit in the empirical evidence. Okay, so the data what we're going to use first contains this administrative data on municipality level tax rates, and we then use some price data that we have already seen in Peter's presentation, which is the IRA retail scanner price data for Germany, which covers the time period from 2013 to 2017. That allows us to observe individual prices of products at the barcode level. Okay. The disadvantage of this data set for our purpose is that the data set does not very well identify the producers. Okay, so it has basically only unclear identity information and no location information about the producer of these barcode level products. So there we do an additional step, namely we web scrape additional producer information data. And that data contains the name of the producer, but importantly also the location, which will then put us in a position to know what the applicable corporate tax rate is. So how do we do this? Well, essentially you observe all these different barcodes. This is one example barcode, and in every barcode there's a part of the number that refers or identifies the company. Okay, so what we essentially do is, for all different company identifiers, take one barcode and plug this into a web search form of the administrator of these barcodes that you can access on the internet. And then the search form will give you information about the producer, in particular the address of the producer. Okay, so if you put in this barcode into the web form, it's going to give you this information. It's going to tell you, this producer, in this case it's some beer, is produced in Frankfurt, and this is the postcode. Okay, so this is more or less enough to identify the municipality. So from this identification, we get our TAU, so the corporate tax rate, which we can then attach back to our barcode. So for every product, we then know the corporate tax rate that the producer has to pay. Our match sample looks as follows. So in the end, we see around 125,000 products produced by almost 5,000 different firms located in 2,000 different municipalities. Okay, and on the left-hand side, you see where these firms are located. Every little area here on this map of Germany, which is not white, is some municipality in which we see at least one producer. And as you can see, there's some gray across this map, which means that there's no change in our sample period in the tax rate, but you also see a lot of orange and red, which indicates that these municipalities have changed and in fact increased their corporate tax rate. And this is the variation in the corporate tax rate that we use in our empirical exercise, which I'm going to turn to right now. Okay, so the identification is essentially a difference in difference strategy. And to explain this, consider the following example. So consider the example of this beer that I just showed you in the web scraping example. Okay, so this beer is produced in Frankfurt, as we have found out. And now, for example, we would observe the retail price of this beer, for example, in Dresden. In a particular store. Okay, so what are the factors that determine this retail price? Well, this could be the demand for this beer in this region. It would also importantly be the production cost, so the unit cost, as we just have learned. And these unit costs might depend on where the firm is located, namely in Frankfurt. But then, as we know from the model, also the tax rate. Okay, so now what we kind of want to do is to regress price changes on tax rate changes, but we want to control for stuff that also matters and thereby sort of control out these demand and production cost effects. Okay, so this is the sense in which we do a difference in difference strategy. We regress price changes on tax changes, but we control for other things, namely we control for demand effects, and we do this by including region by time fixed effects. In particular, we have 2-digit zip codes as regions, so very kind of small areas in Germany. By year, we include this kind of fixed effect, and we include things that control for these production costs. So similarly, we put 2-digit zip code year fixed effects, but now in the production region, and we put unemployment rate changes in the production municipalities, controlling or proxying for wages, and also district level debt growth to control for other aspects of the business cycle. Okay, so we basically do this in a panel regression framework, regressing prices on tax changes. We normalize the net of tax factor such that it corresponds to a tax increase, and therefore the coefficient that we estimate is going to be the elasticity of the price with respect to a tax increase, controlling for the set of fixed effect and these control variables that I just described. Okay, so now I will turn to the results. So this is the regression result first without these control variables, just these very granular fixed effects. And we find that a 1% increase in the tax rates would increase the retail price by 0.5%. Okay, and this is essentially robust to including additional control variables such as the municipality level unemployment rate. Okay, so you get essentially the same coefficient, and you can also add the district level debt, and you get still a very similar coefficient that is very significant. Okay, so this is why we say that there's a very substantial pass through from these prices from these tax rates to retail prices. We also look at the dynamic effect by essentially extending this regression that I just shown you to an event study by controlling for leads and lags of the tax changes. And as you can see, after the initial increase in the price that corresponds to what I just shown you, the price stays up more or less permanently. Okay, so you see that this is kind of now a flat trajectory of the price, and then we see a small fall, maybe also due to estimation uncertainty. Because of I'm short of time, I'm gonna skip the placebo, but I'm happy to come back to that. We also investigate heterogeneity across product categories by interacting the tax change regressor with a dummy that corresponds to a COICOP3 HICP category. Okay, so we have now 20 different categories. What you can see here essentially in our interpretation is that there is some dispersion in the individual pass-through, but there's not really any statistically significant difference between the point estimate that is highest here for milk and so on than for sort of an average effect like wine. And hence we conclude that heterogeneity across product categories seems not so important. It's rather the pooling across different categories that leads to the significant average coefficient that we find. As a last bit of finding, we looked at the role of market share and find it to be apparently not so important. How do we come to this conclusion? Well, here we repeat the baseline regression. We find the average pass-through is 0.42. Then we add an interaction of the text change with an indicator that indicates that a product has sales that are above the median in a market defined by the product category and the region. And we find that this interaction coefficient is essentially insignificant, and hence we conclude that market shares do not play a major role in determining the pass-through from taxes to prices. So to conclude, we found that German municipalities tax their neighbors in the sense that corporate taxes that are set at the local level influence prices far outside these local municipalities in regions all over Germany. So there's a sizable pass-through of local corporate taxes to prices. This indicates that goods market competition is imperfect because it gives price setting power to the producer firms. It also shows that local tax shocks are passed through to retail prices. And in terms of linking back to the political discussion, this would imply that the possible redistributive effects of corporate taxes are somewhat limited. So thanks a lot for the attention. I'm happy to take any questions or go into the robustness results that I did not have time for. Thanks a lot.
So thank you, Timo. I see no questions in the Q&A, nor in the chat. So maybe you can go through the additional results. And
yeah,
feel free to raise your hand and ask questions.
Yeah, thank you. Timo, fantastic that was a fantastic presentation. I liked it a lot. A couple of clarifying questions, I guess, from my end. So these taxes are instituted in the producer facility in the municipality or locality that they're in. Is there an additional, like a consumer tax that gets tacked on to the retail price then in other municipalities that vary?
No, so there's just the aggregate VAT, but this does not vary by municipality. So this is kind of the only local tax that exists in the sense that it would affect retail prices.
Okay, and maybe a follow-up might be: have you thought about running this through these data through some sort of TIBU vote with your feet type model to see if when local municipalities taxes are changed, over time you see firms relocate to other municipalities? I guess. Well, all right, excuse me for being a dumb American, but I'm guessing for beer, that's probably not going to work too well, right? Like there's some tradition there.
that might sort of be maybe related to other costs that you incur by giving up on the tradition, right? So that might not be always optimal. That's a good point. I think that would be a very interesting exercise. It's a great suggestion, actually. We would run right now into a data limitation because we don't really have any time variation in the location of these producers. So we would at the moment not be able to observe it, but we would need to look into whether we can sort of get a different data source that would give us this variation. It's just that sort of the sample of prices refers only to 4 years in the near, not too distant past. So there maybe the effects that we would be able to detect are limited, no? Because I suppose it would also take some time to relocate. But if we looked at a larger time period, I could imagine that this really happens. No, in particular, you could just move to the neighboring municipality, and there could be some tax competition. And then you just sort of move to the neighboring, relocate to the neighbor, and you're fine. So that I find that plausible. Right now, we would not be able to do it, but I think it would be worth looking into it. Yeah, thanks.
Thanks again.
Erwan?
Yeah, I have two short questions that are related. On the last slides, you seem to show that there is some heterogeneity across products. I mean, it's going from above 1 to -1, and I was curious to know whether you tried something to relate this heterogeneity to any observable. You have this exercise with market share, but this exercise with market share tends to show that it's something unrelated to market share, and is it in line with your conclusion that firms can pass through their tax increase because they have some market power? I don't see how it is consistent.
Okay, so on the sort of linking this heterogeneity in product categories to observables, we have not done much. An obvious idea or way to go would be to relate this to a measure of differentiation. So how differentiated is a product? No, and in some categories it might be more so, for example, in beer or wine, while compared to toilet paper, let's say. We have not done that, but that would be something we could do. We kind of looked at it and stared at it and concluded that we don't see an obvious ranking there that would relate to what I just suggested, maybe the differentiation, the level of differentiation. But there might be other dimensions, and we would probably want to look into that, definitely. With respect to what you also said in the beginning, that there is some variation, I totally agree. There is some variation in the point estimates. We did not want to be so bold to conclude that this is really sort of actually there. It could just be statistical uncertainty. No, I mean, the confidence bands are relatively wide, and sort of running a test of these point estimates being unequal to each other would probably not reject the hypothesis, but we haven't formally done it. It's just sort of looking at the numbers. We probably would also, or should do that at some point. I agree. Now to go back to the market share. Well, essentially, I think you can have some market power even though you are a sort of very small firm, in the sense that you don't have a lot of market share, but you still have a differentiated product. If that is the case, you would sort of want to keep your markup constant optimally, also because increasing the price would not be at the expense of market share, actually because it's already so low. So in that sense, in that sense of a kind of a model with CES demand, you have market share, although you have very low. You do have market power, although you have low market share, and in that sense, it's sort of consistent. If that answers the question.
Okay, I see. But coming back, sorry to, but here if you had an estimate for each of the products, you could relate this estimate to some kind of market power. I understand well. Here, this 0.5 is a measure of the market power. From the theory, it is correct.
Yeah, exactly. So with no market power, we would kind of see a zero, because the tax would be sort of just paid by labor or capital, as I said in the beginning. No, and it would not go to consumers. So the fact that it's not zero and something big shows that there's market power. But beyond that, there's no role for the market share. Although this is sort of still a bit work in progress, but this is what we conclude right now.
Okay, I see. Thank you.
Thanks a lot.
So maybe a rejoinder to what Brent said. No, if I have to conclude what we would say about the current politics or interest in the corporate minimum global corporate tax rate, is kind of what you say, no? The redistribution that you could get is, say, if these results, you take them for like literally, it's not a very good tool to redistribute away from capital and towards, say, consumers. But what you said, it still works in terms of international competitiveness, right?
Yeah,
so I think it works more in that direction.
Exactly. Yeah.
No, go ahead.
Agree. Yeah. No, that's exactly right. So the first point is it might not help to redistribute wealth from capital owners to other agents. In particular, also not when we call the finding by Fürst et al., who show that actually increased corporate tax rates lead to lower wages, which goes in the same direction. It's not redistributive in the sense that I just said. So there, it does not work if that was the purpose. But as you say, to kind of limit international tax competition, a global minimum tax would be totally appropriate and sort of unrelated to this finding. Yeah.
On this high note of G20 politics, which is under discussion today, actually in Venice, that's what they're talking about right now, having their aperitif. So thank you very much for resisting this long in this long day of sessions. And I took a copy of the questions in the Q&A. So I will send it to all of us panelists and everybody else whose email I have. So we can also continue these discussions offline. Thanks a lot. And a happy lunch and dinner and rest of the day for all of us. Bye.
Thank you, Chiara.
Thank you.
Thanks a lot.
Have a good weekend.
You too.
Bye.
Have a good weekend. Bye-bye.